Hi folks, I'm going to take a look at number 13 from page 333. So it's a parallelepiped question where they give us three vectors that represent the side lengths of this parallelepiped. All right, so they want us to draw it and then find all vertices. So the way it's set up is all these vectors are given from the origin to a particular point. Okay, so actually makes the problem a little easier. So I'll start by drawing it. And again, here I'm going to make no effort to try to draw it accurately on the 3D in 3 space. All right, so I'll just call this 0 or O, which is 0, 0, 0. So here's one of our vertices. Okay, and we'll have vector A, okay, or OA, and vector OB, and then we'll have vector OC there. Okay, now since this is going from the origin to that point, it means this here will just be the point negative 2, 2, 5. All right, we called this B, so this will be 0, 4, 1, 0, 4, 1, and this C, so that'll be 0, 5, negative 1, 0, 5, negative 1. Okay, and that's C, that's A, and that's B. All right, so if we want to draw the rest of the parallelepiped, well, it's just a matter of drawing out that 3D shape. Okay, so try to be as nice as we can. So we have this base here. So this is going to go there. Again, just try to follow the alternate side there. Try to be as parallel as you can. So here, that one there. There. Oh, a little off on that one. That's fine. Okay, and then okay, so there's our parallelepiped, not too bad. Okay, and we already have 4 of the vertices, so we've got 0, 0, 0, and then the endpoints of those 3 vectors. Okay, so let's give names to these other points. So let's call this, so we already have O, A, B, C, so we'll call this D, we'll call this E, we'll call this F, and then we'll call this G. F, G. All right. All right, so let's now start finding the points. Okay, so let's start with the one on the base here, and I'll use different colors. So if I want to find point D, what I'm going to do is I'm going to draw the vector from the origin to D, and I realize that that's just the diagonal to this parallelogram formed by the vectors OA and OB. Okay, and we know that this vector formed starting at the 2 tails of those vectors is just the sum. Okay, so if I'm looking for OD, that's just going to be OA plus OB. Okay, so OA is negative 2, 2, 5, and OB is 0, 4, 1. All right, so this vector here is going to be, so negative 2 plus 0 is negative 2, 2 plus 4 is 6, and 5 plus 1 is also 6. Okay, so that means point D is negative 2, 6, 6. All right. So now let's continue on. Let's find, say, point E. So point E is that front face of the parallelepiped. Okay, so we see that that's just going to be, again, the diagonal of the parallelogram formed by OB and OC. Okay, so that, again, is just going to be the sum. So OE is just going to be the sum of OB and OC. Okay, so OB is 0, 4, 1. And OC is 0, 5, negative 1. Okay, so what do we have? We end up with 0, 9, 0. Okay, so now let's go to OF here, this point there, and we'll see that's the back face. Okay, and again, it's the diagonal of the parallelogram formed by OA and OC. So OF is just going to be equal to OA plus OC. Okay, so OA, negative 2, 2, 5, and OC is 0, 5, negative 1. All right, so negative 2 plus 0, negative 2, 2 plus 5 is 7, and 5 minus 1 is 4. Okay, and lastly, we've got, okay, not too good there. We've got vector going to G, okay, which is going through the parallelogram. And here we can see that it's just going to be the sum of the three vectors, because it's OB plus OA. I just moved that one there, and then plus OC. Okay, so it's just the sum of the three vectors, which is going to get us to this opposite diagonal point from point O. Okay, so here OG. Okay, so it doesn't really matter how we add them up. So I'll just add them up in order: OA plus OB plus OC, and that's due to the fact that vector addition is commutative. So what do we have? OA is negative 2, 2, 5, plus OB is 0, 4, 1, plus OC is 0, 5, negative 1. Okay, so we add those together. We got negative 2 plus 0 is negative 2. 2 plus 4 is 6, plus 5 is 11, and then 5 plus 1 is 6, minus 1 is 5. Okay, and there we go. So what are the missing points? All right, so we had the original vertices, which were 0, 0, 0. What do we have? Negative 2, 2, 5, 0, 5, negative 1, and 0, 4, 1. So those were the original four vertices that we had, and now we found the other four, so negative 2, 6, 6. Then we had here, what was this one here? 0, 9, 0. All right, then we had negative 2, 7, 4. And lastly, the one that was directly across point O is negative 2, 11, 5. 1, 2, 3, 4, 5, 6, 7, 8. So we've got all of them. All right, so step number one here in terms of drawing this parallelepiped is don't worry about being precise on Cartesian 3 space. Okay, just draw it out as you would a rectangular prism. Okay, now in this case here, because we were actually given the vectors, okay, we didn't have to do what we did with the original parallelogram question, which is create the vectors and then use that to solve the problem. Here we were able to just use the fact that we were always dealing with diagonals of parallelograms, which involve just the sum of the two vectors, and then finally to get the diagonal straight across, we needed to add all three vectors together. Okay, that's it for this one.